So I'm going to close this series of demonstration and also remove the current files from our project. I'm going to exclude them from project, and I actually already preserved this sample as source underscore copy new. Again, this is not part of our actual source code, but for your reference, these two subfolders contain the source code that we already tried and be able to compile. So we're moving to the next and final part of our laboratory exercise right here, and we're gonna start building a running total calculator. So once again, I am downloading the prototype files into this source subfolder, and so these are the running total prototype files. So I'm just going to start downloading, starting with the main. Save this link, and actually just watch out that you should be downloading from the download links, so that's the right approach here. So I'm just going to save, and all of these files will appear right here. When you finish downloading, there should be like 6 files in this subfolder. So let's now the next step is to after removing prior source examples from our source files, we're going to once again include all CPP files and the ASM file as a set of source files for our application. So I'm going to right click on source files, add existing items, and we're looking at new set of files. So I press Control key down and click each CPP and ASM file, altogether 4 files. So there are 2 header files in this prototype. So these are the 4 files. I'm going to say add to our project, and right now I'm just going to build this code and run the prototype to examine its initial behavior. So build solution, and so it compiles fine, and now I'm going to run it. Control F5, press Control F5 to execute the program, and so this is how it starts, and it basically tells us that this is a running total calculator, and what we can do here, we can use arithmetic operators plus, minus, multiply, divide, percent for remainder or modulo, and also assignment to be able to assign new value to the running total. So as it makes progress through this user interface, it prompts for the total value, which is currently 0 at the beginning, and it's using the default arithmetic operator plus. So if I type number 10, for instance, and hit enter, you see how 10 gets accumulated. And so it tells me that 0 plus 10 equals 10. If I send, say, 20 right now, 10 plus 20 is 30, and then it waits for the next operation. But if I want to use different operator, not necessarily plus, for instance, I can try to use division. So now I can say, okay, let's divide by 2, and so the result is 15. So you see that it's not exactly the running total, but it's basically the running value calculator, right? So you can use multiple operators, and the operators that we are going to support is plus, minus, multiply, divide, percent, which is a calculation of the remainder or modulo operator, and also assignment. So we can just basically say equals 100, okay, and this should basically replace the current total with the fixed total. So if I hit enter right now, it tells me that the equal operator, assignment operator here, is unimplemented. So this is part of a set of tasks that we need to be able to complete to finish this laboratory exercise. So I'll probably provide an example. So this is an example of user interface. Here all the values are highlighted. And in the current prototype, the one that we just downloaded here, the plus and division arithmetic operators are implemented. The rest of the operators are not implemented, but we will follow the instructions on how to implement them. So this is the idea of this program. And what's interesting about it, about this prototype, is that in this current implementation that we have in the set of these source files and a couple of header files, we're using C++ functions, and we're using C++ standard library to deal with user input, to display the calculation result. So all the user interface handling largely is done inside C++ functions. The actual math, the pluses, minuses, division, multiplication, all of this is implemented inside the assembly module that we include in this program. So all of the C++ code is finished. The only remaining work is assembly module. So we're just going to be focusing on assembly module. We're going to walk over its structure, what it has, and all the proposed steps to move forward with the completion of this module. So in order to do the work here, C++ invokes the procedure which is called M13_calculate. And that's the procedure. This is the public procedure inside this assembly module. Okay, so right here, M13 calculate is a public procedure, and this public declaration makes it visible outside of our assembly module and makes it available for calls from C++ code. Okay, so what else? Let's just walk through the entire setup of these files, and first let's examine implementation functions as it is done in C++, and then we will switch our full attention to the assembly module which implements these operators like pluses, minuses, multiplication, and so forth. So let's take a look at the C++ side of things before we continue to examine the assembly code.